I'm going to write up my solutions for the Algebra test 2019 level 2, which was very difficult. It's been in the news and I certainly concur that it is quite hard, unusually hard. The first one is reasonably standard, but it's a hard standard, so we put everything on one side, and then it's a matter of finding the two factors that work. We know this one only splits into 3 and 1, so the two brackets are going to be 3x and 1x. But the question is, what are the other two numbers? There will be factors of 6, so either 2 and 3 or 6 and 1, with one of them being, sorry, that's an arrow, with one of them being negative. So you can try 3 times 2 is 6 and 3 is 3. 6 and 3 doesn't add or subtract to 7. But if you swap them, 3 and times 3 is 9. 1 times 2 is 2. 9 and 2, yeah, that subtracts to 7. So that is the solution. And it'll be 3x plus 2 and x minus 3. I wrote 1x, but it's really just x. So it's not too bad, but it is one of the trickier ones. This one doesn't look like a quadratic unless you multiply through times x squared on both sides, and you will get 3 plus 4x equals 5x squared. And then if you put everything on one side, 5x squared minus 4x minus 3, then you have equals 0, which is what we need. This one does not factorize, so you have to use another method. One method you could use is the quadratic formula. So x is negative b plus minus square root of b squared minus 4 times a times c, which turns out as plus 60, over 2a, which is 10. This is 76. You can simplify it depending on how much you love algebra. 76 in here is 4 times 19. And you can pull out that 4 out of the root as a 2. So it's 4 plus minus 2 root 19 over 10. And then you can divide everything by 2. This, and this. And you will get 2 plus minus root 19 over 5. And I leave the calculator solution to you. That's the boring bit. So one solvable by factorization, the other only by brute force quadratic formula. This one is very similar again. It's a brute force. You write everything down, this function, and you fill in 9.18 is the initial one, so for time equals 0. If that's 0, this is all gone except k, so k is 9.18. So you have a simplified formula. Then how long till c is 5.05? So the setup is 5.05 is 0.02 t squared minus 0.6 t plus 9.18. And of course that all has to go on one side again. 0 is 0.02 t squared minus 0.6 t plus 4.13. And then it's a brute force. Of course the calculator can tell you, or with the quadratic formula, 0.6 plus minus square root of 0.6 squared minus 4 times 0.02 times 4.13, all divided by 2a, which is 0.04. And so you will get 0.6 plus minus 0.172 or so over 0.04. The two answers in the end are 19.3 or 10.7. The next question is, this polynomial can be written as a perfect square. This is a code word for only one solution, or a double solution is another way they like to say it. So the idea is a perfect square. So if it can be written like that, it would be something like p of x equal some sort of bracket. There could be something in front, something like ax minus b squared. No plus anything, meaning there is no shift up or down in y direction, and so it will be a parabola that touches the x-axis somewhere, determined by b divided by a. So I think it's b divided by a. but it's not up or down, so it's only a single solution, so you don't get the case that there are no solutions which would be floating above, or two solutions which would intersect. So as soon as you realize that, actually we're looking for that discriminant b squared minus 4ac, and we want to show that it is 0. And that is easier said than done. Let me just consult my notes. So to do that, we will have to square this thing. This is b, of course, this is a, and this is c. So once you do that, let me just write it out. It is quite awful. Minus 4 to m minus 1 m minus 4, and you want to show that this is 0, or you want to find the value of m if it can be done. So we assume it can be done. You multiply this out, so you have to expand all that. In the end, or near the end, it comes to m squared plus 2m plus 1. That's this part. And this part, after some work, is minus 8m squared plus 36m minus 16 equals 0. And when you join them all up, all the m squares minus 7m squared, all the m's is plus 38m, and then minus 15 with these bits equals 0. And again, that's a quadratic formula or solver or something. So you can, I'm quite fond of the quadratic formula, so I'm going to do it that way. Plus minus square root of 38 squared, b squared, right? Minus 4ac, so minus 4 times minus 7 times minus 15. And over 2a, so minus 14. And after dealing with this, I'm going to skip a little bit. You will get minus 38 plus minus, oh sorry, this is 38. That's right, sorry. 32 over negative 14, which simplifies down, if you want, to minus 19 plus minus 16 over 7. Over, yeah, minus 7, actually. Oh no, just 7. Where am I going wrong? This is minus 14, apologies. And in the end, you get, I think, 3/7 or 5. And those are the two answers. I may have messed up the minuses. I think I did. So 19. No, I think that's right, actually. No. All right. So these are the two answers. And if you try them, certainly if you try 5, you will get 9x squared plus 6x plus 1, and that's obviously a perfect square. If you try it with the 7ths, it will also work. As long as you take the 7th out, or negative a 7th, you will get x squared minus 10x plus 2 answers for that one. So not very easy. The difference between the roots of this equation, so this assumes the fundamental theorem of algebra that this expression can be rewritten as px minus a times px minus b. I say p because obviously it's going to be p squared here, so p squared x squared is probably easier to write it like that. So they obviously each have to have a p, but then there's, okay, now you could expand this out, and then you get something x squared and something x and a constant, and then compare with these and set up equations. But the easier thing is, if you can handle it, is to do the sum and product thing. So the two numbers here need to multiply to minus 12 or negative 12, and the two, once you multiply them, so pxb and pxa, both negative, need to add to 4px. So using that, as long as the p doesn't bother you too much, you can also come up with this. So this is px minus 2, px minus 6. And then if you multiply them, you get negative 12, that's true. If you add them, so minus 6px and minus, no, one of them is plus, sorry. This one. So if you multiply them, it's negative 12. Yeah, this one is 6px minus 2px is indeed 4px. So this is the factorization, and of course this is still equal to 0. From this you get two solutions. Either x is 2 over p. So if this is 0, you can put the 2 on the other side. Px is 2, so x is 2 over p. And if this is the culprit that made it all 0, then x must be negative 6 over p. And because you put this on the other side, this is equal to 0, you put 6 on the other side, divide by p. These are the two roots, and now it says find an expression for the difference between them. So I would say 2 over p minus negative 6 over p, which is the same as 2 over p plus 6 over p in its common denominator, so it's 8 over p. And that is, in my opinion, the answer. Of course, I don't have access to the proper solution, so I could be wrong, but it looks good to me. Okay, here we want to show that this crosses the x-axis at two distinct points. That's the same thing as before with the discriminant being greater than 0. You probably know this, but in this quadratic formula, negative b, plus minus square root of b squared minus 4ac all over 2a. If this part under the root is negative, well then you have root of negative, so you get no solutions in the real numbers. If this is 0, then you get one solution, because you have negative b plus minus nothing, so the plus minus becomes pointless, so you just have one solution. Although some people call it a double solution, or two solutions that are the same. So that's slightly philosophical, but it does show up under those descriptions in the exams. And finally, if this is just positive, then you just get two good old solutions, so plus minus something. And that's what we're shooting for. So we're shooting for b squared minus 4ac in the quadratic formula being positive. So to show that, you have to first, the way I did it is multiply this thing out. And once you multiply it out, so FOIL it out, you get x squared minus ax minus bx plus ab minus c squared. And then if you combine these, so this is 1x squared, if you will, this is minus a plus b if you factorize, and then plus ab minus c squared. Now in these ones, a, b, c, these are of course the numbers or the coefficients of the equation. So this is a in quotation marks. In the quadratic formula, this is b, and all of that really with the plus as well is c. So as long as you don't mind me recycling these letters and using them twice, I'll now set up b squared minus 4ac in the quadratic formula. So this is the discriminant, which discriminates between the three cases, two solutions, one or none. And as you set this up, you first have to square this thing. Now the minus is going to drop off. I'm not even going to bother because I'm squaring. So I'm just going to square that part. Then minus 4 times a, which is nice, is 1, and c, so it's all that stuff, ab minus c squared. And then I expand that and I get a squared plus 2ab plus b squared from this part alone, and then this minus 4 stuff is minus 4ab plus 4c squared. Then I play with this. I want to show somehow that this is never negative and never even 0. It's always positive. So as long as, well actually it could be 0, we'll get to that. So I played around with it and I threw these two together. Actually, sorry, all I did was combine these and I get a squared minus 2ab plus b squared plus c squared. Is that right? Plus 4c squared. I think that's right. So this one looks like a binomial formula. This is in fact a minus b bracket squared, so you have to realize that, and this is plus 4c squared, and then you're done, but you have to kind of realize it. This is always greater than or equal to 0 because it's squared. Whatever these two numbers are, the worst you can do is that they're 0 if you put the same numbers. n squared is 0. But otherwise, if they're not the same, then you'll always get something positive because it's squared. This is also always greater than or equal to 0, but I'll be even stricter because it's actually greater than 0, because we know that c is not ever 0. So that means this whole thing is always greater than 0. So the discriminant is greater than 0, therefore you have two solutions. Okay, moving on. Some relief comes in question 2 because it starts off quite easy. This one is simply the power of half, which you can multiply, but you have to distribute to each and every one of them. So that 9 to the power of half, of course, is the root of 9, which is 3. Here you multiply the powers. Power of 2 times half is a, and negative 4 times half is negative 2. B to the negative 2. You're not allowed to leave negative indices, so we throw that one down in the basement as b squared, and there you go. Here, the easiest thing to do is if you realize that minus is the same as 1 over, power of negative, so, and 1 over is the same as the reciprocal, or the flipped upside down version of this one, so 4 over 2a squared, after I flip it, and then I got rid of that minus. And then I just distribute this to each and every one by the law of distribution. So this should be 9b to the 8 over 4a squared. For b, the solution to this one relies on realizing that these can be factorized. So this one is c plus 3, c minus 3. It's the third binomial formula, and then we are looking for that here as well, one of them anyway. So we factorize into two brackets, and we figure out it's c minus 3, c minus 1, because they multiply to plus 3 and add to negative 4. So to make this into a common denominator, what have we not got in each? This one hasn't got c take away 1, so I'm going to give it that, top and bottom. And this one is missing c plus 3, so I'm going to give it c plus 3 top and bottom, of course, otherwise illegal. And I've ignored what was already there up till now, 2c plus 1 and c take away 2. I'm going to put brackets around them because I'm about to multiply these out. This is all the same denominator, so I'll already put them on the same. C plus 3, c minus 3, c minus 1. And then here I multiply this out. This is 2c squared plus c minus 2c, so foiling it out, minus 1, and this one is plus c squared plus 3c minus 2c minus 6. I hope I did that right, please do double check. And then once the dust settles up there, when you join like terms, you should get 3c squared minus 7. The denominator, I'm tempted exactly like that. That's clean, that's simple to me, but some might argue you should expand it. I don't think so, however. C plus 3, c minus 3. Okay, there you go. That should be it. Not too bad. Like I said, question 2 is bringing some relief in the difficulty level of these questions. Factorizing this one fully. This is one of those double brackets where you have to split it in the middle. But before you split it, you actually have to shuffle it a bit. Because these two have nothing really in common. And neither do these. But these two have something in common, that f, and these two have that g in common. So what I did is I swapped the order of these two. And I wrote fm plus 3fn minus 6gn minus 2gm. So just swapping the order of these two with their sign in front, please. And then the trick with these, if it works, is to just do the two halves separately. So here I'm factorizing out whatever is possible. Actually only f. So this leaves m plus 3n. And here I also separately look at what can I factorize, and I can factorize a minus 2 or negative 2g, and that leaves in here 3n, and then this becomes a plus m, and then I realize, whoa, this is actually the same thing. I can pull that out on the right or on the left, whatever you feel like. I'll go alphabetical, 3n plus m, or m plus 3n, it's really the same. And if I factor that out, what is left here is f take away 2g. And that should be the factorization. This one has been in the media as having a mistake, and that is true. It does contradict. But actually the solution is kind of nice and straightforward if you just ignore that contradiction at the end. So as long as you don't notice the contradiction, you're probably okay. This is given as area 9. And so one way to do it is to look at this one and say, well, this is y take away 8 is one side, the other side is y. So y times y take away 8 is 9. Once you expand that, so you multiply that out, create a quadratic equation, yet another one, there are many in this one, you should get this equals 0. And then you can factorize that as y take away 9 y plus 1 equals 0, and this gives the solutions that either y is 9 or y is -1. Of course, -1 is nonsense. You can't have negative measurements. My measuring tape doesn't have any negatives, sorry. So this is the solution I'll go with, y equals 9. And then we figure out some other things. So for instance, we want to find out what is that length here. Now that we have y, we are able to find it. So if we add them two together, add the two together, y take away 8 and y plus 2. And by the way, that's equal to x. So that's how we also get x. And so this x, and then we put in the fact that we know y is 9. So 2 times 9 minus 6 is x. And so that's 18 take away 6, so x is 12. And so we have the fact that this is 12. And then what about this one here? This is x take away 4. I'm sorry. So this is 12. Then 12 take away 4 is 8. So we now know that this side is 8. And so the area of the rectangle ABCD, it just fits, is 12 times 8. Which is 96. However, the inconsistency is the fact that this is 8, but this here, y alone, we figured out to be 9. So that's impossible, of course, because this y needs to be shorter than that side. So that's the problem. Yeah. You also have an issue here, I think, that, I don't know if you can get this area as 9. So this is, this is 9. That's fine. I think that's 1 by 1. That's okay. So the contradiction is here, as we used to do in maths at uni, a lightning bolt for contradiction. Can't be. But if you don't see that, then you're probably away, and I'm guessing that they will give you all marks for getting this far. Okay, the fun continues. For page 7. This is actually not too long, but it certainly is a little bit iffy. The fundamental theorem of algebra that if you happen to have two roots, then you should be able to write this one as two brackets, and say a is one root and the other one is n times a. Anyway, like this. You should be able to write it like that if you have the two roots. So we do that, and I leave this one here, x plus q. Sorry, that's a q, not a 9. And if you multiply this out, you will get x squared minus nax minus ax plus na squared. You can subtract x squared on both sides, and then we simply compare. Sorry, I'll do one more step. So I want to figure out how many x's are there. And so if I factor out x, I'll get negative na minus a. And so if I compare, p must be equal to that, because that is what's in front of the x. I think this is called coefficient comparison. So p must be, and then at the same time, hope you don't mind, I'm going to factor out negative a. And this is n plus 1. And so, right, okay. So I get that one. At the same time, comparing these coefficients, q must be na squared. Now it's a matter of showing that you have this one. It's hard to aim for that, Well, we want to show now, I think what we're going to do, let me try to remember, is put them together. Oh yeah, we need to get rid of a. Sorry, there is no a in this equation, so I need to get rid of it. So one way I could do it is solve this for a squared and stick it in here. That will work best, however, if this is a squared. I really don't want to deal with roots, so I'm going to square this thing. So to the power of 2, and so I get p squared is, now negative times negative is positive, that's nice, a squared, and then that's n plus 1 squared. The squares distribute over multiplication. And then I'm going to replace, so I know, hold on, that, oh no, I'm going to do this one, p squared, I'm trying to make sense of my scribbles. So, oh yeah, once we expand that one, so this is going to be n squared plus 2n plus 1, and then I just slapped on a squared, so I get a squared n squared plus 2n a squared plus a squared, and then I replaced. So I did sort of a clever substitution where I said, hold on, na squared is q, so this is, if I take 1a aside, that's, sorry, 1n aside, that's na squared, so I get nq here. Here that's exactly q, na squared, so I get plus 2q, and then a squared. What is a squared? A squared is q over n, isn't it? So this is q over n. Sorry, they're all q's, there are no 9's in this writing. And then this is ugly. Let's, with that division by n, let me multiply everything by n. np squared is n squared q plus 2nq, and here plus q rather than q over n. And as I put all of that on one side, I will get qn squared. I swap these around because that's what it says in the solution. So I get qn squared, then I will get plus 2qn, and then I minus this one to that side, minus p squared n plus q equals 0, or 0 equals, whatever, and then I factorize that one. So I pull out n, and if I pull n out of here and out of there, I'm left with 2q minus p squared plus q equals 0. And this is what was to be shown, or as we used to write QED. It's certainly difficult algebra, so don't be put off by the fact that I seem to have gone there in a straight line, but it is quite tricky to not make a mistake and get to that point. Again, some relief, at least in my opinion, comes in question 3 at first. Here, the way I like to do logs is I like to read it out as 5 to what power is m minus 3? So 5 to what power is m take away 3? Because that's the question that the log asks, is the base to what power is the argument. So 5 to what power is m take away 3? And the answer is given, 0. So 5 to the 0 is m minus 3. So 5 to the 0, so m must be 4. Okay. And of course it is true because 4 take away 3 is 1, and any log of 1 is 0. So there's a easier way to do it, just in a one-liner, if you just realize that. Here we use the log rules backwards. First of all, we're going to stick that back into the power. So we'll write log 6. This assumes some sort of base b, but we're being lazy and not writing it. Minus log y squared, so that 2 can go back. That's the third log rule. And then this minus can turn into a division inside the log. So this is 6 over y squared, and that should be the answer. The next one is fairly nasty again, although kind of standard for how these things roll, but it does take a lot of work to get there. The idea behind it, or the principle, is that if you have, say, 3 to the 7, you can split off a 3 and say, well, that's 3 times 3 to the 6, because power rules or index laws tell us that we can add these, right? So it's like you split off 1 3 and take that one down by 1. So first of all, what I'll do is I'll leave all of them I kind of want to find the smallest one. It'll become clear. And this one I will rewrite as 3 squared to the n minus 2. What can happen here, because 9 is 3 squared, you see I'm putting everything into 3's. Now these get multiplied out, so this is 3 to the 2n minus 1 plus 3 to the 2n plus 1, and this one I'm going to multiply out, and it is minus 3 to the 2n minus 4. This one is the smallest, so I'll try to bring everything into that one. So I'm going to take this one down 3 notches till it says 2n minus 4. So I'll say 3 cubed times 3 to the 2n minus 4. Here, same thing. Of course, to take this one down to negative 4, I'm going to have to get out 3 to the 5 times 3 to the 2n minus 4. And here, this is going to be 3 to the 4 times 3 to the 2n minus 4. And here's just minus 1, 3 to the 2n minus 4. Then I factor all those out. You can do this bit by bit. I did it when I first solved this. I did that actually, which is maybe a little bit easier, but this is the direct way, I suppose. Then you can factor out 3 to the 2n minus 4. Sorry, 2n minus 4. And so here on the left you will get 3 cubed, that's a 3, plus 3 to the 5. And here you will get, so same thing at the bottom. You should get 3 to the 4 minus 1, because there's only 1. These cancel. This is a beautiful moment. And 3 cubed is 27. This one, 3 to the 5, lordy lordy, 3 to the 4 is 81 times 3 is 243, I believe. I'm going to check that in a moment with a calculator. And, oh yeah, no, that's right, because that'll be 278. And this is 80, t 80ths, or 27/8. And I think that's the answer. Okay, question 9, exponential growth. This is quite nice. Actually, this is very standard. So you want to find out how long is it till we have triple the number that we started with. If you're a novice at this, you might do this. You might say n0 times 1.053 repeatedly multiplied, t times, is in the end triple of what we started with, but then you realize you can actually cancel that. So the experienced one will just go there, 1.053 to the t. The only way to get to the t is if you put logs on here, so we're just going to slap a log on both sides, any log. You'll use the log base 10 or ln. If you've worked with ln, probably at this level you will just use log base 10, but both work as long as you do the same. Hold on, so this is 1.053 to the t, and then we use that rule that you can bring it to the front that we used backwards the other day, the other moment, sorry, the other question, seems like days. 0.053, and then you simply divide by this stuff to get rid of it, log 1.053. On both sides. And experienced students will skip a few of these steps. So it's really log 3 over log 1.053. And the answer, I haven't actually figured it out yet. Let me figure it out real quick. Should be, so log 3 divided by log 1.053, and is 21.3 or so. And this is weeks. Okay, here's another one with a percentage, and we want to assume the form of the model still applies. So really what's happening is that we start with 2,500, we multiply by some sort of rate. Now this is the R percent, so it's 1 point, R hundredths. I'm just going to write big R, and yeah, this with the understanding that big R is, 1 plus R hundredths or something. So R is just that little part. So here, for instance, R is here, and it's 5.3%, which is divided by 100 and added to 1. I'm just going to make life easy, call it big R. So that big R, which is 1 point, and then whatever the rate is, to the power of 10, because it's 10 weeks, will result in a number of 4 to 50. First you divide by 2,500, both sides, just to get rid of that, make it simple. So R to the 10 is that. I didn't actually figure out what that is. I'll cancel a 10, so I'll write 425 over 250, and then you have to take the root. It's always that way in these exponential problems. I always say if you need the rate, if you want the rate, you need the root. So R is the 10th root of that stuff. It does actually simplify. Sorry, this is the 10th root of 17. And if you do that, so you have to find the right button. Here it is, where is it? I haven't done this for a while. You have to do the 10th root of 17, and it is 1.328. And so the percentage is actually this part. So the rate is 32.8%. Yeah. Okay. And this is the final question. Actually, I found this probably the easiest. It's a simple fitting of a quadratic. This, by the way, is 67. You can, if you want, just assume that this is 0. So reset the x's to be there, and then take that 67 off that value as well. That'll make it a bit easier. But then you'll have to take it off here. So I'm not going to do that. I'm just going to use it as is. So I'm going to use that formula. H equals, where is it? K times x take away 640 squared plus 67. And we need to find out what K is. So we are given one point, this point right here, which is the point 1280, 227. So I'm going to put that point in. 227 is K times 1280 take away 640 squared plus 67. And if you figure that one out, so you take the 67 off here and you get 160, and you divide by all that stuff. Anyway, long story short, K is a quarter. Okay, so you can put that in here again into the original equation because you now know what K is. Finally, we want to find out, so I'll do it. So H is a quarter. X take away 640 squared plus 67, and this is our modeling formula. And now we need to find out, well, when is the height 100? So you stick 100 in here and find the x for which this is going to happen. X take away 640 squared plus 67, and so you have to take off 67. So 100 take away 67 is 33 times 4, so it's 132. Is x take away 640 squared. You take the square root of this one, which is roughly 11.5. I've rounded, but of course plus minus, and this is x take away 640. So x is 640 plus or minus 11.5, and so these are the 2 points, in fact, for which you will get 100. Oh, sorry, I've moved on again. Not too bad. So which one are we going to choose? The one to the left of the middle, according to the picture. So plus, and just go with the minus, and we should get 638.5. So a few quite tricky bits in here. Quite difficult, especially the first question, which wouldn't put you in a very happy mindset doing this exam. Please do check my answers, because I'm only human. But I'm hoping this will give you an idea of how to solve this one.